Well, hello everyone. So we were so rudely interrupted by the bell today, and prior to that, we were kind of in the middle of this problem. So I'm going to review the problem a little bit and then talk about the final part. So we were talking about volume of a pyramid, in this case, a square-based pyramid. And we all know that the volume of a square-based pyramid is 1/3 big B, which is area of the base, square, times height. And the height, of course, has to be measured perpendicular to the base. And that's way back when from geometry, but it's good to review it, and we know it's true, but calculus will allow us to prove it, which is very cool. We talked about establishing the a slice of this pyramid after we had rotated it and imposed it upon an XY coordinate plane, origin here at the apex of the pyramid. And we can take a slice out, a vertical slice out of that pyramid, and anywhere we do that, the vertical slice will be in the shape of a square, and it will have width S and height S, and later we'll give it some thickness so we can deal with volume. But for right now, we can say this is S times S, or S squared, is the area of that vertical slice. So then if we want to, we can say that the area, let me make some more room here. The area of that slice then, with respect to x, is x squared. A of x equal s squared. And then the volume with respect to x would be s squared times delta x. I had that up here. I want to say that. Delta x, of course, represents the thickness of that little slice, and that just infinitesimally tiny, tiny, tiny thickness, delta x. And so we have area, s squared, times a thickness, delta x, gives us a volume. And then the whole idea is that we'll put in a bunch of these slices along here, stack them up using the integral sign to take the sum of all those slices, and we can then determine the volume of the entire pyramid itself. Earlier today, we talked about, I guess I could bring this back down. Earlier today, we talked about one problem is that we have the area in terms of S, and we need everything in terms of x. In other words, the thickness of this is in x, delta x. And so we want everything in terms of x if we can get it, just one variable. So we talked about this morning how this triangle here has a height of h. The base we'll call L, big L. And the destination, the location of our slice is x units away from the origin. I don't know why I put a P in here. I don't know if that's even necessary. Muddy the water. So because these two triangles, this triangle here, maybe I'll give it some color, this green triangle here is proportionate to the big red triangle, we can then set up a proportion. And I don't even think I need that one. I was going to go that route this morning. We can say that x, this horizontal distance x, is to the big horizontal distance h, as s is to, you guessed it, L. And so we can then try to solve for s and then substitute in these other terms once we get that into this equation, s squared. So we can cross multiply. Someone suggested that today. S times H equals X times L. Divide by H, and we have S equals XL over H. And this morning we talked about, gosh, look at all these variables. And we said, well, but L and H appear to be variables, but they're really not. They are just going to be dimensions in this triangle. And the only variable is going to be S, the distance from the origin, and that will slide back and forth. So we're actually okay, even though it looks like it. Those guys are going to be constants, L and H. So then we're in pretty good shape. We had said earlier that the area with respect to X is, well, not even with respect to X. We'll say the area equals S squared times delta X. And then we were going to substitute this expression in for S. So we can say then that the area with respect to X equals XL over H. And again, L represented the length of the base, and X the distance of our slice from the origin, and H is the height of the triangle, and later the pyramid measured perpendicular to the base. Okay? So now we have the area with respect to X equals S squared, but we didn't want S. We wanted to express that in terms of X, so it's still squared times delta X, the thickness of our slice. Oh, shoot, I put that in a little bit too early. Man, I'm getting off here. I'm tired. 7:30 and I need to go home. So the area with respect to X equals X big L over H quantity squared. So let's square those and recall then that we need to go X squared over H squared times L squared. I'm going to reorder these a little bit just to make our lives easier. How about area with respect to X equals L squared over H squared times X squared? Because we want to treat these guys as constants and work with this separately if we can. Okay, so that's pretty good. Now, let's bring that delta X in that I had mistakenly put there earlier. We said the volume with respect to X then is L squared over H squared times X squared times delta X. So notice we have an area times a thickness gives us volume. So we're doing pretty well. So then if we want to stack up all those volumes like we talked about, then we can just take the volume of the entire pyramid equals the integral. Now, I should bring this down, clone it, copy it, whatever. I think that would make life a lot easier. Maybe I can do that. I'm going to give it a try. So bear with me here. I'm going to clone this and drag it down. Oh, shoot, I lost it. Oh, it's getting worse. Getting worse. Undo, undo. Okay, I better group it and then drag it down. We'll try. Okay, this time it'll work, I think. And then we can see what we're talking about. Okay, sorry for that delay there, but I think it was good to have this. Now, keep in mind in this drawing, we're no longer using S, but we've expressed that S in a different way. But we do have this height here, H, And we have this length here, L. And the S, maybe I can sneak in there gently, we said was, there it is, up right there. It's XL over H is now the height and, in fact, the width of this, both, of that slice. So you've got the height of the triangle, or the, in this case, pyramid, the height of the pyramid measured perpendicular to the base, the length of one side, L, or the other side, because it's a square base. And so now we can say that the limits of integration go from 0 to H, 0 to H. I'm going to put that in, 0 to H. And then we want to do one slice. Volume of one slice then is going to be L squared over H squared times X squared times, instead of delta X, we're going to go dx. So notice that this part right here, the X squared, is a two-dimensional. The dx is a one-dimensional. So two-dimensional times a one-dimensional gives us a three-dimensional. Or in other terms, you could say it's a third-degree polynomial. Gives us a volume. Again, remember the L squared and the H squared, we don't have to worry about those are constants. I mean, we'll deal with them, but for right now, if you want to, you can move them outside of the integral sign. I whistled there a little bit. X squared dx. So now we can go ahead and integrate that and say the volume equals L squared over H squared of, okay, X, add 1 to the third, multiplied by the reciprocal, 1/3 X cubed, evaluated from 0 to H. So now we have the volume equals L squared over H squared times 1/3 H cubed. See, notice I just took my upper limit of integration, put it in, substituted in for X, cubed it, minus 1/3 my lower limit of integration, 0 cubed. Okay, so now we have the volume equals L squared over H squared times 1/3 H cubed. And now let's put these together. The volume equals L squared over H squared times H cubed. I'm going to bring that 1/3 in front since it's 1/3 L squared over H squared times H cubed. Well, I'm going to divide that by H squared and that by H squared, and that leaves me with just H. So now I have volume equals 1/3 L squared times H. Now recall that L squared, is area, I lost an E there, area of the base, which compares very favorably to our earlier equation. Volume equals 1/3 big B, area of the base, times H. So we expressed it a little bit differently, but it is the same, and it works, and that is the power of the calculus, ladies and gentlemen. So we came in under 15 minutes. I hope this is helpful on your quiz tomorrow, and have a great night. Bye now.